Hi everyone, my name is Lacey and I'm a master's student studying marine ecosystems and society in the Shark Research and Conservation Program at University of Miami. And in this episode of Seas by Degrees, I want to show you that anyone can be a marine scientist if they want to be. It is a common assumption that in order to be a marine scientist or study the ocean, that you have to know how to swim, that you have to know how to scuba dive and spend lots of time on boats. Basically, that you have to be comfortable in, on, underwater. But for people who are passionate about marine organisms and the ocean, who don't like the water or afraid of the ocean, are not comfortable on boats, don't know how to swim, have never even seen the ocean, and don't know if they'll get a chance to, these assumptions and requirements might make it seem like becoming a marine scientist is inaccessible to you. That you can't become a marine scientist because you can't do any of these things, you don't know how, or maybe you don't want to. Maybe you love sharks and want to save them, but you don't want to get in the water with them. One of the most common questions that I get when people find out that I study sharks is, do you scuba dive? Do you get to get in the water with them? And the good news for all you ocean lovers, but maybe ocean fearers, is the answer for me is actually no. My research focuses on the natural predatory interactions between great white sharks and Cape fur seals around Robert Peninsula in Plettenberg Bay, South Africa. The seals are located along the northern coast of the peninsula, and the sharks swim up and down searching for and hunting them. In order to collect my data, I sit on the hiking trails that cut through the rocky cliffs that make up this peninsula, and I record the activity going on below me using a notebook and a drone. I am literally sitting there and watching all day. I don't set foot on the beach, I don't set foot on a boat or touch the ocean. My study site was chosen specifically for this reason too, so that I could study the natural predatory interactions completely non-invasively, without my presence, without a boat, without bait, without anything man-made that you normally see people using to study sharks that could potentially influence their behavior. Essentially, I'm just spying on them. And my project is just one example. In our lab, for example, we conduct shark tagging trips in Biscayne Bay here in Miami. And during our tagging trips, we'll take muscle samples, fin clip samples, and blood samples that we'll send to collaborators in Arizona, others at and in Brazil to analyze in their labs. The point being that sometimes the data that you are actually analyzing for a project, you don't have to collect yourself. It can be really collaborative. And collaborative studies are all abound in marine science. Another great example is acoustic telemetry, which is a common tagging technique used to study movement and spatial use of sharks and other marine organisms. Animals are fitted with an acoustic tag, and underwater listening stations or receivers are placed in various locations that pick up the signals the tags give off when the animal swims within the detection range. So how is this collaborative? One researcher's listening station will pick up not only their animals, but all the other animals that are tagged that swim within that receiver's range. However, sometimes the battery life on the tags actually outlasts the project's and the researcher's interest. So there might be a bunch of animals that are still getting recorded, but there's no one actually analyzing that data. Let's say you're a tech person who loves sharks, but you don't want to be in the field with them. You could be the person that collaborates with an owner of an acoustic receiver to analyze all that additional data that's coming in from those tagged animals. I love to say that teamwork makes the dream work. And collaborative studies are just a perfect example of another way that you can get involved in marine science research and conservation while still staying dry. But the list still goes on and on. My drone, for example, is another tool. They've been around for a while, used in other various aspects. They're still pretty new in marine science research, and we're just figuring out all of the different ways that they can be used to collect data for us, making previously inaccessible areas more reachable, expanding our ability to conduct non-invasive research just like mine, collecting samples that we never knew we could collect, like whale blowhole spray, without actually having to be out there near the whales. Basically, they can make it easier to study the ocean at a distance. There are so many different ways that you can study the ocean and the organisms that live in and around it and depend on it. And technology is developing so fast that by the time you get to high school, college, or graduate school, the tools that you might use don't exist yet. It could very well be that it's the combination of your passion for jellyfish and your love of robotics and your fear of the ocean that creates a new tool that we can use to conduct marine science research. An example that proves that you do not have to give up on that dream if physically being in, near, on, under the ocean is not for you. Thanks so much for joining me with this episode of Seas by Degrees. Bye.